Now it is. Okay. So we have positive and negative 4. Any questions there? Let's look at 12. It's an equation. It's quadratic. It's got an x squared term, but it's missing the x. So I can use this method. I can add 100 to both sides. I'll get x squared equals 100. Then I take the square root on both sides. And when you do that, you must put in plus or minus. So that's something you want to remember. Every single time you take the square root on both sides of an equation, you must look at both the positive and negative answer. So plus or minus, now the square root of 100 is 10, right? Because 10 squared, 10 times 10 is 100. So we get 2 answers, positive 10 and negative 10. So far, this is pretty straightforward. Any issues? Does anyone see what's going to happen here on number 13? What are we going to do when we isolate the x squared? What do we have to do to both sides first?
Subtract 25 from the left side.
Subtract 25, yeah, subtract 25. So that's going to give me x squared equals negative 25. Okay, so let's just follow the procedure. Let's take the square root on both sides. We're going to do plus or minus, because every time we take the square root, we have to. So the left side is x. Now, right side is plus or minus. Now, what is the square root of negative 25? So that negative causes an issue, right?
Don't you have to do like the I?
The I, yeah, exactly. So the way that you need to start thinking about it is every time you see a negative under a square root, just know that that negative is just going to turn into an I. So we know we're going to get an I, but we also have to do the square root of 25, which is what?
5.
5. So we're going to have 5i. So we actually have 2 answers. We have positive 5i and negative 5i. Let's look at number 14.
So negative's always going to be negative square is always going to be an I.
You'll always have an I. If you'd like, what you can do is anytime you see a negative under a square root, just scratch out the negative and put an I on the outside. Just make sure that the I is, separated from the square root. But always expect that you're going to get an I when you have a negative under a square root. On number 14, we will subtract 88 on both sides. Okay, so we get x squared equals, what is that, negative 81. Then I have to take the square root on both sides. I have to do plus or minus. The left side will be x. The right side, plus or minus. Because I see a negative under the root, I know I'm just going to get an I. I'm going to put it in the back. And then what's the square root of 81? 9, right? So just 9i. Plus or minus 9i. 2 answers. Okay, let's do number 15. I would subtract 7, subtract 7. I get x squared equals negative 3. I would take the square root on both sides and do it on the next line. Now I know that I'm going to get an I to pop out, right? So I'm going to get x equals, I'm going to get an I to pop out. I have my plus or minus. Here's my I, I'm going to put it in the back. But don't I still have to do the square root of 3? I do, right? And what is the square root of 3? That's not a number you should be familiar with. So we have to do it on a calculator. Get about 1.73. So I'm going to put 1.73i. So that one's a little different because the square root, the number, wasn't something that we know. We had to resort to the calculator to do it. Any questions there? Let's look at 18. Yeah, let's look at 18. Oh, you know what? Let's look at 23. Let's look at 23. So for 23, it's an equation, it's quadratic, and we're missing the x term. So we can use this method, but we have to isolate the x squared. So the first thing I'm going to do is add 6 to both sides. That'll leave me with the negative 8x squared. And on the right side, what do I get? Negative 24. When I take negative 30 and add 6. Now, do I take the square root now? This is the first time we've run into this. Should I take the square root now, or do I have to do something else first?
Gotta get rid of the negative 8.
Yeah, we need to get rid of that. We need it to be just x squared. So to get rid of that negative 8, what am I going to do on both sides? You may have said it, I didn't hear.
Negative 8.
Do what with it though?
Divided by negative 8.
Divide, yeah. So we're going to divide both sides by negative 8. That'll give us x squared equals, okay, so negative 24 divided by negative 8, that's positive 3. And now I will take the square root on both sides, plus or minus square root of 3. And it's not negative 3, right? It's just 3. So I don't have to worry about an I here. And we just did square root of 3 on our calculators. So this should be plus or minus 1.73. Any questions? Okay, let's look at one of these with a fraction in it. I'm thinking I'm like in number 26. Hold on a second. Oh my gosh. How did I get into the homework? Did I get into the homework? Factoring. No. Okay, 26. So I have an equation, it's quadratic, it's missing the x term, but I also have fractions. And we've dealt with this before. When we've had fractions before in equations and we want to make our lives easier, we clear the fractions. So that's what I'm going to do. I'm going to multiply both sides of this equation by 12 because that is the least common multiple of the two denominators, 3 and 4. So I'm going to multiply the left-hand side by 12. Whatever I do to the left, I have to do to the right. So I'm going to multiply the right-hand side by 12. So when I distribute this through, this multiplication, I'm hoping that you've come comfortable where you could do that on your own without me having to show you all the steps. I'm going to write down what this will become. 9x squared plus 4 equals 0 still on the right side. Okay, so distribute. And now I don't have fractions. And now that problem looks a lot like the ones we've done. I will subtract 4 on both sides. That'll give me 9x squared equals negative 4. And next step is to divide by 9 because I need a 1 out in front of that x squared. So I divide by 9. That'll give me the x squared equals negative 4 over 9. And at this point, I can use the square root property. So I can take the square root on both sides. When I do that, I have to do plus or minus every single time. Negative 4 over 9. So we have a couple of bad things here. We have the negative underneath the root. So I'm going to have an I in my answer. I'm just going to go ahead and write that down now. I know that I'm going to have an I. So I don't have to worry about the negative anymore. But then I have to still take the square root of 4 over 9. And I told you earlier that you could just split that up and do them separately. So do the square root of 4 on top, square root of 9 on the bottom. So you should get 2 on the top and 3 on the bottom. And what am I missing? I'm missing something here. I've got the I for the negative under the root. I've got the 2/3, which is the square root of 4/9. What am I missing?
Plus or minus.
Plus or minus. Okay, good. Plus or minus. I mean, think about it. If you miss the plus or minus on, like, let's say the test, you don't put plus or minus, you're missing half the answers, right? You've got one of the 2 answers. So you want to make sure you have that in there. Okay. All right. That's it for the square root property or square root method. Like I said, it's good, but then it falls apart when if you have an x term in there with the x squared term, you can't use the method. All right. Okay. So quadratic formula. So here's the quadratic formula. Maybe you've seen this before. But the way this formula works is like this. If you have a quadratic equation, any quadratic equation, as long as you've got the variable in there, it's squared, that's all you need, and it has to be an equals in there. Then if you can write it like this, where you have everything on one side equal to 0, it's very important that we have it equal to 0. Then if you just identify the number in front of x squared, that's a, the number in front of x, which is b, and the number that's by itself here, c, then all you have to do is plug them into this formula and it automatically spits out the answer. So let's do one example of solving using this formula, and then I'll ask you whether or not you want to know where the formula came from or not. Some people could care less, let's just move on. But if you're interested to see it, I can actually show you where that formula came from. But let's see it in action first. So let's take a look at this first one here. Solve this using the quadratic formula. So first of all, do we have a quadratic equation? Yes, right? We have an equation. We've got our variable, it's squared. Are we missing the x term? Not this time, right? We have the 4x in there, the minus 4x. So we cannot use the square root method from before, which was relatively easy. We move a number over and take square root plus or minus, not that bad. So we cannot use that here. So what can we do? Well, your options are, you only have 2 options left. You can either factor it or you can use a quadratic formula, right? They're telling us to use a quadratic formula, but I'm just going to tell you right now, you cannot do this by factoring. Okay, you could try it, it's not going to work. So if you try and factor that, you're going to get stuck. And I told you the quadratic formula always works. So students start to get to the point where they just use the quadratic formula all the time because it doesn't require you actually having to think about anything other than plugging numbers in. Okay, so does this quadratic equation look like what it's supposed to look like? Does it look like ax squared plus bx plus c equals 0? So does it look like that? Well, it's equal to 0, so we've got that part. It is equal to 0, right? Equals 0, got that. And I think we can identify the numbers in front. We have a 1 in front of the x squared, that's our a. We've got a -4, make sure you pick up the negative there. The b for us would be -4, and the c would be that -3. So we do have the form we need, right? So we can just, I like to just write down what a, b, and c are. A is 1, b is -4, and c is -3. Okay, so once we know what a, b, and c are, we can go to the formula. And the formula, it's above us right here, but I'll write it down on the side so we can see it. The formula says that our answers, x, will be -b plus or minus the square root of b squared minus 4 times a times c, all of that, the entire thing divided by 2a. Okay, that's our quadratic formula. So we're just going to do what we refer to in math as plug and chug. We're just going to plug in our answers and then chug out, or plug in our numbers and chug out the answer. So the first thing I need to do is figure out what negative b is. So in the formula, negative b means the opposite of b. The opposite. So what is b for us? B is
-4.
-4. We want the opposite of -4. So what's the opposite of -4?
4.
+4. So I'm going to put +4 here. Then I'm going to put plus or minus the square root. Now, the next thing that we need is b squared. That's whatever b is, right? Whatever our b is, square it. So our b is -4. And -4 squared would be
16.
16. And that will always be a positive number, right? In this formula, what b squared will always be positive. So we'll have 16, then minus, because there's a minus sign here, then 4, because it's a 4 here, and it's always a 4. And now I need to multiply times a. So I'm going to put in parentheses, a is 1 for us. And then I have to multiply by c, which is -3. And then I take the whole thing and divide that by 2 times a, and a is 1. Okay, so from here, we just need to clean this up and simplify it. We just need to figure out what the answer is. And I hope that you see that this right here that we're looking at looks kind of like what we started with today. You can kind of see it in here, that we were doing that computation and like doing these things right here because we kind of were trying to prepare you for this part right here, where we have to actually, sorry about that. Okay, where we have to actually figure this thing out. So I'm going to highlight the part that most students mess up. Most students can get this far, all right? Like they have no issues getting to here. The part that most students mess up is putting those numbers together right there. That's your next step, is to put all those numbers together. And what they usually mess up is the sign. Like they do, okay, I can do 4 times 1 times 3. I know that that's going to multiply to be 12, but is it positive or -12? And the reason it's so messed up, or messes students up, is because you have, negatives in different places. So I have an easy way to kind of remember. I want you to look at the number of minus signs you have. We have 2 minus signs, don't we? If you have an even number of minus signs, your answer is positive. Okay, if you have an odd number of minus signs, then your answer will be negative. We'll do another example and you'll see what I mean. So even, you'll have positive, odd, you'll have negative. So my next line here is going to be 4 plus or minus square root. This 16 I'm not even talking about yet, just the part in the yellow there. I know it's going to be plus because there's 2 negatives. That's 2 is even, so I know it's going to be a plus there. And I know that those numbers multiplied to be 12. And then I put all of that over 2. 2 times 1 is 2. Now, underneath the root, I have to do 16 times 12. I'm sorry, 16 plus 12. 16 plus 12 is 28. And then all of that divided by 2. And now this looks like a problem from earlier. So I'm just going to get on my calculator now. And I'm going to do the square root of 28. .29, so I'm going to say 5.29 over 2. All right, and now I have 2 different things to do. Maybe I should do this below. I have to do 4 plus 5.29 over 2, and then I have to do 4 minus 5.29, and then over 2. So 2 separate problems to do because I have a plus or minus there. So I'm just going to do both of those and give you the answers. Trusting that you could do that on your own on your calculator, you should be able to get 4.65 for this one. And this one's going to be negative. You're actually going to have negative 0.6. I'm going to round 2 decimal places. Please make sure that you can get those on your own calculator, because I don't want you to get to the test and then have never practiced on your calculator. Any questions? Okay, here's what I'd like to do. I'd like to see if you can practice right now. So I don't even know, I know how many of you are here. I wanted to try the breakout rooms, but I'm not sure how many people. Well, let's do this. I want you to try right now to work out numbers 29 and 30 on your own, okay? Feel free to talk to one another here. Those are both quadratic equations. On both of them, you have to use a quadratic formula. Let me just remind you that before you can use a quadratic formula, it has to look like ax squared plus bx plus c equals 0. So is number 29 in that form yet?
No.
No. Okay, nor is 30. So let's see if you can get them both to look like that. Then identify A, B, and C, and then use the quadratic formula. And I'll write down the formula here for you just so you have it again. And why don't I give you 10 minutes to see how far you can get. And you know what, just for fun, I'm gonna break y'all out into two breakout rooms. And this will actually show me who's actually here and who's actually not. So let's see, we're gonna just do 2 breakout rooms. So you're gonna get an invitation and go ahead and join those rooms. All right, everyone. All right, I'm showing the work for the first one. So were there any questions or any trouble that you may have run into on the first one? Got to get everything over to one side first, identify A, B, and C, and then go through the formula. I'll also point out that we had two negative signs. Since we had two negative signs, that's why we have a +8. And then after that, it's just a matter of doing your calculations correctly. Now, number 30, I don't think everyone got to number 30, so I'd like to work through number 30 quickly. The first thing you have to do is get the right side to be 0, so you have to subtract 1 on both sides. And that gives you x squared minus 3x plus 5 equals 0. And then at this point, you can identify A, B, and C. So A is 1, B is -3, and C is 5. And then we're going to just go and plug it into the formula. So I'm going to erase this and just work it out under here. Okay, so my answers will be x is -b, which is the opposite of b. So we have -3, so the opposite is +3, plus or minus square root. Now you have to square b, right? That's the formula. So 9 minus 4 times a, which is 1, times c, which is 5. All of that over 2 times 1. Now, count the negative signs. How many negative signs do you see there?
One.
Just
One.
one, right? Just one. That's an odd number. And so it's going to be a subtraction. So I'm going to have x equals 3 plus or minus. Now, be careful here. The subtraction is not on the 9. It's after the 9 is a minus. And then just multiply those numbers together. 4 times 1 times 5, that's 20. All over 2. And now this is 3 plus or minus the square root. Now here, 9 take away 20 is -11. And now we have that special case where we have a negative underneath that root. And so we know we're going to get 2 answers, but we're going to have an I, and we're going to have to stop. So 3 plus or minus, I know I have an I, but I still have to do the square root of 11, which I'll do on my calculator. 3.32. And I'll just stop here. Are there any questions there? So for number 29, we didn't have an I, and we got 2 nice numbers as answers. Number 30, we had a negative under the root, so we had an I and we had to stop.
I think that's where I got confused on 29 because I was messing up my signs and I ended with an I, so I stopped there for 29.
Did you have -11 under there?
No, for 29 I had a negative and
Oh, got you.
yeah, so I was mixing it up because my signs were like all over the place.
Okay. Yeah, and that's the thing, you're just gonna have to practice because like once you understand what you're supposed to do, it's just a matter of getting good at it without making mistakes. Because all you're doing is plugging numbers in. So we've got more here to work through, okay? What I'd like to do, it's 12:15, I've been giving everyone a 10-minute break. You know, let's go ahead and take a break now. We'll come back at 12:25. We'll finish up a few more examples. And then after that, we'll get into kind of like the whole idea of this, which is some applications. All right, so let's take a 10-minute break. Okay, everyone, let's take a look now at number 32. It's the first one where we actually have a fraction, some fractions involved. But it's an equation, it's quadratic. It has the x term, so we can't use the short method or the square root method. So we have to use quadratic formula or factoring. So I'm going to multiply both sides by 4 because that's my LCD. So I multiply the left side by 4, and I multiply the right side by 4. And when I distribute, let's see what I get. 4x squared minus 6x minus 1 equals 4 times 0, which is still 0. So that's my new quadratic equation. And it has the form that we need to use the formula. I can see that A is 4, B is -6, and C is -1. I'm going to work through this one. So my solution will be, or my two solutions will be -b, which for me is +6, the opposite of -6, plus or minus the square root. And now I'm going to square -6, so that's 36, minus 4 times A, which is 4, times C, which is -1. And all of that over 2 times A, and A is 4, so 2 times 4. I'm going to count my negative signs. I've got 2 of them, so I know I'm going to be doing a plus here. So 6 plus or minus square root 36, it's going to be a plus. And then I'm just going to multiply these numbers, 4, 4, and 1. That's 16. And then on the bottom, I have 2 times 4, which is 8. So 6 plus or minus the square root, what is that? 52 over 8. And now I'm going to get on my calculator and do the square root of 52, which is 7.21. So I get 6 plus or minus 7.21 over 8. And then I'm going to go and get my 2 answers. So you might see me do this. Like this is what I get when I use the plus, and this is the minus. So 6 plus 7.21 over 8. This one is 6 minus 7.21 over 8. So I'm going to go ahead and just do those real quick. And you'll just want to check that you can get the same answer on your calculator. So make sure you're typing this in properly. 1.65. And the other one, you should get negative 0.15. There we go. So that problem was just like the ones before, but we had to clear the fractions first. Any questions there? Okay, let's see, all of these. Let's look at number 38. I'm not going to do the whole thing, but it's the first one where we have decimals. So we would want to get rid of the decimals, and I can see that the second one has a 1, 2, 3. If I can move that decimal point over 3 places, it would no longer have be a decimal. It'd be a nice number. So I need to move the decimal point 3 places everywhere. So this first one, I move 1, 2, 3. So I'm going to have 250 x squared minus 1125x equals, and then 0, it doesn't matter where you move the decimal place, it's still 0. And here, this one's a little bit different because, well, these are big numbers, but it is a quadratic equation. I do have that x term, so I'm going to have to use either factoring or I can use the quadratic formula. And in this one, it actually works out easier if you factor it, because you can just pull out an x right now. they both have at least one x. So I can pull out a GCF on that step. And now that I have multiplication, I can just set each one of these equal to 0. So I can set x equal to 0, and I can set 250x minus 1125 equal to 0. And the first one, the answer is 0, just x is 0. And the other one, I have to add 1125 to both sides, and then divide by 250. So I get 4.5. There we go. Now, had you not done that, had you not seen that you could factor, you would have to realize that this is really, if you're going to use a quadratic formula, A would be 250, B would be negative 1125, and C here would be 0 because you don't have a number there. Well, you do, it's 0, there's nothing there. So you would have to see that C would be 0 in the formula. So you just got to be careful with that. That was the first example I've given you where that happens. So just notice the difference between that and like the ones up here where we did have a C, right? We did have something there. It was a -1 up here. So if you're ever missing that C, you can just do factoring GCF. Okay, so I think at this point, it's going to be important for you to just go through the homework and practice, all right? Because there's quite a few things that you need to get proficient with. But I think I'm ready to move on. I'm looking at your homework here. So it tells you here, use the square root method for these. Here you'll have to clear some fractions. Then this says use quadratic formula. So, you know, get everything to one side. Here you'll want to move the decimal places. More decimal places. Here's some fractions. There's a good mixture of problems there. All right, we are ready to get into graphing. So we're going to talk about functions again. So remember the notation we used for functions was this f of x. If we ever have a function that looks like this, this is what's known as a quadratic function. Not a quadratic equation. The equation was when we had a quadratic equal to 0. This is just a quadratic function. So I'll give you a specific example. Like if we did something like 2x squared minus 4x plus 3. That would be an example of a quadratic function. It has the variable x and squared, and that's what makes it quadratic. But again, it's not an equation, it's a function. So we have already talked about how when you have functions, you can make a table and plug in numbers for the input and the output, and then you can draw a picture of all those points. Well, we know that if it's a linear function, then when you plot the points, it'll look like a line. But the question is, what do quadratic functions look like? And that's what this next part of this section is about. Or next part of, the graphing section. So it turns out that if you have a quadratic function, all right, that your graph must look like one of these two. And these things are called parabolas. And your parabola is either going to look like a U that opens up like this. Okay, so we'll call this a parabola that opens up. Or it's going to be a U shape that opens down. It's going to be one or the other. Okay, all parabolas either open up or down, or all quadratic functions either open up or down. Now, there's an easy way to determine whether or not it's going to open up or down. All you have to do is look at what A is, the number in front. Okay, that number A will tell you if it opens up or down. So I'm going to put underneath here, the parabola will open up if A is a positive number greater than 0, and the parabola opens down if A is a negative number. So one way you can remember this is kind of cheesy, but you know, the parabola that opens up looks like a smile, and positive people like to smile. So if A is positive, you have a smile, and if A is negative, you have a frown. So it opens down. Now, with all parabolas, you also have this thing called the axis of symmetry. And all the axis of symmetry is a line. I'm going to draw it on here. It's a line that goes right down the middle of the smile or the frown. That line is like a mirror line. Your parabola is a perfect reflection of itself over that line. So if you were to take the left side of the parabola, here in yellow, and reflect it over that blue line, it would land right on top of the other side. So it's like a little mirror. We call it the axis of symmetry. So there's a way to get the axis of symmetry. Okay, it's not super simple. I will explain it in a second. I'm going to leave this as an open question. Okay, where we get that. All right, so when it comes to parabolas, all right, I want to kind of explain why parabolas are important. All right, so why are, before we get into actually graphing and stuff, why are parabolas important? All right, so I have several examples. First of all, it's better if I'm in a classroom. I can do this because I can get a volunteer and we can stand on opposite sides of the room. And what I can, if you can imagine, if you throw something through the air, right? Let me grab something here. So if you take something and you throw it through the air, it's going to lob through the air, right? And all objects on Earth, okay, if you throw something through the air, like a ball, the path that it travels through the air is always a parabola, always. Okay, it's never a straight line. There's always a curve to it because of gravity. So this right here, for every object that's thrown on Earth, there is some quadratic function that tells you everything you need to know. We don't know it right off the bat, but for every parabolic path, there's always some quadratic function that would tell you all the information you need about every point on that path. So let's say, you know, you're trying to, you know, go back into history, right? And I think I told you this example before. You have, you know, like a castle, and here's my castle. Those are the little towers. And you're trying, you know, these people are coming in here and they're trying to break into the castle and steal all the food and gold and everything, right? So they start lobbing like things, arrows and fireballs and cannonballs, whatever. They start lobbing them into the castle. Well, if you actually understood the mathematics behind these parabolas and the flight of these objects, you could actually predict and determine where you want them to hit. Like you could calculate that. Like, okay, we need to take out something over here. We could make the correct adjustments to hit that target exactly because we understand the math behind the parabola. So, you know, warfare, like I've talked to you about in the past, has motivated, you know, advances in mathematics. But there's many other places that parabolas appear. Another place, something more common, I guess, that you see every day. If you think about a headlight on a car, right? Well, think about a light bulb in a room, right? If you have a light bulb in a room, okay, here's my light bulb. You have light coming out in every direction, right? But when you're driving down the road and you have your headlights on, your light's more like a beam. It's like a beam of light. And so the way that they do that, the way that you actually can get a beam of light, is you put a light bulb. Okay, so I'm going to put it sideways. Here's a little light bulb. Put a light bulb here. So light's coming out from in every direction. And then what you do is around it, you put a parabola. Now this parabola is sideways. Okay, you put a parabola, and that parabola is a mirror. Okay, it's a reflective mirror, and it's shaped as a parabola. Not a circle, not a half circle. It has to be perfectly a parabola. And then it has this property that every beam of light that hits it will bounce off and come straight out. Doesn't matter where it hits, it comes straight out. So all these light all these photons or whatever come out straight, no matter where it hits. And what you do is, instead of scattering out light in every direction, you have a focused beam of light instead. And that's how headlights work. All right, if you ever look, you'll have a light bulb in there and you have this reflective material behind it, and it's shaped like a parabola. And if you've ever used a flashlight, flashlights work on the same principle. If this were a flashlight, let's say this were a flashlight, I know a lot of you know that on flashlights, if you turn the top of it, the beam will go and spread out and come back together. And all that's doing is, when you're turning that thing at the end of the flashlight, it's moving this parabola in and out. And as you move that parabola back and forth, it causes the reflection angle to change. So when beams come out, they don't go out straight exactly, they come out a little bit slightly at an angle. And so you wind up getting this very wide beam of light. It's not as bright because it's spread out, but you can spread the light on the flashlight, and then you can bring it together by turning it. So all of that relies on a parabolic mirror for this to work. Okay, so, but it has to be a parabola. It can't be, like I said, it can't be a half circle. Circles aren't parabolas. So, and then one other thing that you see, or that you use parabolas for, that you're not even thinking about, is when you're sitting here on your cell phone, right? There's your old cell phone there. And you're talking, right? Like, let's say you make a phone call. Your phone sends out a signal in every direction, basically. You have this signal going out. And then somewhere near you, within a mile or so of you, there's cell phone towers all over the place, right? And in these towers, I don't know if you ever seen, they've got these weird like boxes, these box things on top of the towers that go around in a circle. And those boxes, if you were to open them up, inside they have like little, they're like parabolic, that's terrible. It would be parabolic, okay? And so what's happening is the signal's coming in here, and it's the reverse of the headlight. Instead of beams, light coming out, you've got this signal that's going in, it's bouncing off, and there's a little receiver at the end of this, and all the beams get focused onto this receiver. So this tower kind of is listening, catches your signal using a parabola to bring it in. And then what it does is, after it catches your signal, it sends it out to the next tower, right? So here's you, here's one tower, and then there's another tower over here. So it catches your signal, amplifies it, sends it out again everywhere. This tower catches it and then sends it, and it keeps going. And then there's another person over here that receives your call, right? So their phone is listening and gets that. So there's that connection from you through the towers to the other person. But all of that capturing of the signal relies on these parabolic mirrors, or parabolic surfaces, to capture the signal. And if you want to think of it in an even bigger scope, if you look at the Earth, if you want to communicate with somebody on the other side of the planet, right, then you can't do towers all the way around because there's oceans. So what do? We send the signal to a tower. All right, the signal goes to a tower, and then there's a satellite sitting up here in space, and the signal gets sent to the satellite, which has a parabolic receiver on it, captures the signal, sends it to another satellite, and then back down to a tower, and then to that person. And all of that happens at the speed of light. So you call someone on the other side of the world, your signal goes speed of light through all these parabolic receivers and to the other person. So a lot of our communication with one another relies on parabolas. So I hope that that gives you some sense of the importance of parabolas in the real world. What we're going to be doing here is we're just going to practice graphing them. All right. So if somebody were to give us a parabolic function or a quadratic function, the question is, can we graph? Can we graph it? Oh man. Lost my spot again. Okay. Okay, so with all these parabolas, we know if they open up or down. We can tell by the A, if A is positive, it's up, A is negative, it's down. Now, there's some other important points on parabolas. Okay, I'm going to erase some of this stuff, get it out of our way. Okay, so there's a very important point on a parabola, which on the parabola on the left, if a parabola opens up, this would be the lowest point on the graph. Okay, this is known as the vertex. And on the parabola that opens down, it would be the highest point on the graph, right? It's known as the vertex. So the vertex of a parabola is a very important point because it tells you either the lowest the parabola ever goes or the highest it ever goes. And we actually have a formula that allows us to find this point. Now, keep in mind that the vertex is a point, right? So it has an ordered pair. There's like an X coordinate and a Y coordinate. But we don't call it X and Y because it's a very special point. We call it H and we call it K. So this vertex here has some X coordinate H and some Y coordinate K. Now, how do we find H and K? If somebody gives us a quadratic function, how do we actually find that highest and lowest point? Well, we have a formula, and the formula actually comes from calculus. It's something you can do in calculus to prove, but here, I'm just going to give you the formula. So here's the vertex formula. Okay, if you want to know what H is, all you have to do is do this computation. Take negative B and divide it by 2 times A, and that's it. That'll tell you what H is. Now, what's B and what's A? Well, just go back. Remember, A, B, and C are just those numbers, just like we had in the quadratic formula. The A, B, and the C are things that we need to know. And once we know what they are, they'll allow us to find the vertex. So we can find H by calculating that. And then to find K, what we do, this may look weird. What we're going to do is we're going to take the answer we got for H, whatever that answer is, we're going to take it and we're going to plug it into the function, and that will be the K. So I'll go through an example, but there's the formula for you. Let's get to an example. I think I want to just work one out. You know what? One more thing before we actually do this. So let's say I have a parabola. This is a question for everyone. If I tell you that I'm going to draw a parabola that opens up or down, doesn't matter which way, does it have to hit the x-axis? Yes or no? Does a parabola have to hit the x-axis? What do y'all think?
No?
No, it doesn't. Uh-oh. Looks like my program is having issues here. Hold on. Looks like my program is crashing. What did I do? I'll try and close it out. So if it doesn't have to, can you all still see my screen okay?
Yes.
I mean, see a screen. Okay, so how about this? If I draw a parabola that goes like this, and I tell you that the vertex is right here, then that would not hit the x-axis, right? So it is possible to have a parabola that does not hit the x-axis. Is it possible to have a parabola that only hits the x-axis one time?
No.
No? You sure? How could I draw a parabola to only hit the x-axis once?
Wouldn't the vertex be on the x-axis?
Yeah, your vertex would have to be on the x-axis, and then it would only hit one time, right? And then, of course, it's possible to have it hit twice if your vertex is like this. I should also point out that these parabolas that look like little U's, those U's keep widening out. They keep going forever, wider and wider and wider. All right, so it's not like a true U. It's not like this. It's not like this where it goes straight up. Okay, that's not it. Okay, it has to widen as it goes. So when it comes to X-intercepts, there's three possibilities. If I tell you, hey, you got a parabola. When it comes to the X-intercepts, you have three different things that could happen. You could have two X-intercepts, you could have one X-intercept, or you could have no X-intercepts. Do you agree? Those are the three possibilities. How about Y-intercepts? What do y'all think about Y-intercepts? If I draw a parabola, how many Y-intercepts can I have? Is it possible to have none?
Yes.
How would you have none? So let's say I put the vertex over here. Well, you know what? Let's put it like, let's put the vertex way over here. So the parabola is going to start opening up like this, right? Well, it's just going to keep going up and up, but it's going to keep moving to the right, isn't it? Like if you were to go way up here, which I can't go any further, but you know, it's going to keep spreading out. Isn't it going to hit somewhere up there? Like it's going to eventually spread out and go and hit that side, hit that y-axis somewhere?
Yes.
No matter how you draw your parabola, you've got to hit it at least once. But you can't hit it more than once, all right? So there's a limit. Whoa, there's a limit to how many. So the y-intercept will always have one. Okay, so I'm going to now give you a set of steps on how to sketch a quadratic function. All right, here they are. Steps to sketch a quadratic function. First step. The first thing we're going to do is determine if it opens up or down. And that part should be easy because all we have to do is look at what A is. The second thing we're going to do is we're going to find the vertex. And we're going to do that using the formula I gave you before. After we find the vertex, we're going to do what I refer to as a quick sketch. A quick sketch. And from this quick sketch, you'll be able to answer this question: how many X-intercepts you have. Step 4 is going to be to find the X-intercepts if you have any. If you have any. And the way you find X-intercepts is you set the function equal to 0. And that means you're going to be setting the quadratic equal to 0, which means you'll be solving a quadratic equation, which is what we just finished doing. So the whole reason we were doing the previous section is so that we could do step 4 of this process. And step 5 will be to find the Y-intercept. And step 6 will be to do a final graph, a final sketch. Oh, and how do you find the Y-intercept? You do this. You calculate f of 0. You plug 0 into the function. So that's it. Those are the steps. Take a moment to jot those down because we'll need those as we move in to the problems. All right. I think we're ready. Okay, so we're going to graph this function right here. All right, that's what we're going to do. I'm actually going to, I don't know if I can select that. I don't think I can. No, it won't let me. Okay, I think I'm going to do this on a new page. Negative 2x squared. Here we go. All right, so this is it. This is the big thing that you need to be able to do for the test next week. A lot of the stuff we've done up to this point was to build up to this one problem. So if I give you one of these, it's going to cover a lot of the stuff we've already done. So I would anticipate seeing several problems like this. You're being asked here to sketch this. Okay, sketch this. So first step, does this thing open up or down?
Down.
Down, why?
Because -2, well, I mean the 2 is negative.
Down because A equals -2, which is less than 0. It's negative, negative people frown, right? So we know that this is a parabola that opens down. While we're here, why don't we just identify what A, B, and C are? Because we're going to need it for the problem. A was -2, B is 4, and C is 1. Do y'all agree? Okay,
Yeah.
good. So we know it opens down. All right, second step. We want to find the vertex. So for us, the vertex is either the lowest point on the graph or the highest point on the graph. In this case, is it lowest or highest?
Highest.
Highest because it opens down, right? So if it opens down, we have a highest peak. Okay, so to do this, we're going to use a formula. H is equal to -b over 2a. So for us, what is negative b? The opposite of b.
-4.
It would be -4, right? -4 over 2 times a, but for a for us is -2, isn't it? So we're just plugging into the formula using the a and the b that are given to us by the function. This should give us -4 over -4. -4 over -4 is +1. Okay, so we know what h is. H is 1. Now we find k. And to find k, all we do is we take the answer we just got, 1, and plug it into the function. And we've done this before. We have the function here. It's been given to us. And now all we need to do is plug 1 into it. So we plug 1 in, -2, we got 1, we square it, plus 4 times 1, and then +1. So we got to be real careful here, order of operations. We're going to do the 1 squared first, which is just 1. And then we'll multiply that times -2. So we get -2 times 1 plus 4 times 1 plus 1. This is -2 plus 4 plus 1. We should get 3 here. So remember, the vertex is a point. And what we're saying is that if you look at this point on the graph, it's the point 1, 3, right? This was h and this was k. So that is an actual point that we can plot on the graph. Any questions on the vertex? Okay, what was the next step?
Quick sketch.
Quick sketch, right? Okay, so this is what I mean by a quick sketch. And I'll tell you right now that if you ever talk to any tutors or friends that are doing this and sketching quadratics, I've never seen a textbook or a tutor or anyone that does it this way. I've always just done it this way because I think it makes the most sense. This step right here, this quick sketch, let's go through it and you'll see why I think it's useful. Okay, I'm just going to draw a very quick sketch. Okay, I'm going to put my vertex. My vertex is the point 1, 3, which means I move to the right 1 and up 3. And when I say quick, I mean just, it doesn't have to be perfect. There it is, right? There's your vertex. That's the highest point on your graph, and your parabola opens down, doesn't it? So if I were to do a quick sketch, that would be the basic idea of what I have, isn't it? So can you tell me from that picture how many x-intercepts I have?
2.
2. I have to have 2. Just from that quick little picture, I have 2 x-intercepts. What if this parabola would have opened up and we had that vertex? How many x-intercepts would we have?
1.
We'd have none, right? So do you see how the quick sketch can really like quickly tell you how many x-intercepts you have? And that takes you to step 4, which is what? Finding the x-intercepts? So what if we didn't have any x-intercepts? What would we do? We just skip this step, okay? We'd skip it. And this step is long, so we don't want to do it if there was no need to. All right, so we're going to find the x-intercepts. And how do we find the x-intercepts? I said you set the function equal to 0, right? Well, here's your function up here. You have to set that equal to 0. That's this step. So I have to set -2x squared plus 4x plus 1 equal to 0. And notice now we have a quadratic equation, right? We have a quadratic equation, which is what we were talking about from the beginning of class today. So there are 3 different ways to solve a quadratic equation. We can try and factor it. We can use the square root method if it looks a certain way, and then we use a quadratic formula. I can already tell I can't use the second method, the square root method, because I have an x term. I have x squared and x, so I can't do square root method. Would you all like to try and factor a quadratic formula? I think you're not going to have success factoring. I think quadratic formula is going to be required here. That's why I say most people start leaning towards the quadratic formula. So I'm going to write down again what my A, B, and C are, because we need these for the quadratic formula, don't we? And then just plug in to get our answer. X is equal to negative B, which would be -4 plus or minus square root. We square the B, 4 squared, minus 4 times A, which is -2, times C, which is 1, the whole thing over 2 times -2. So do you see why we spend time doing quadratic equations first? That way when we get to this step of this bigger problem, we can do something we've already seen before. I have 2 negative signs here. So we'll have -4 plus or minus 16. Will it be plus or minus there? So I have 2 negatives. I forgot, what is it?
You got a positive.
Got a positive, thank you. Okay, and then we have 4 times 2 times 1, so that's 8. So we're going to go 8 there. On the bottom, we have -4. This is -4 plus or minus square root of, let's see, 16 plus 8 is 24, all over -4. Hey, can I cancel these -4s right here?
Yeah.
You have to be careful. Remember that division bar. Remember what I told you about this division bar? That division bar says you must do everything on top first before you divide by -4. So we have to figure out everything up there before we can actually do that. So that's a common mistake. That's why I brought it up. Do not try and cancel those things out. Wait until you do everything on top first, then divide by -4. So it's almost like it puts this in, oh, that was not what I meant to do. It's almost like it puts this in parentheses and says, do all that first. That's what that long division bar means.
All over my laptop.
Okay, continuing. I need to get my calculator out.
You're gonna
I need to do square root 24. So I get, I don't know, I'm going to round that to 4.9.
You're gonna just think that you're making excuses every
I
time.
know
now.
they are. They really are.
-4.
Am I really another person?
Okay. So now we get our 2 answers. All right, so I'm just going to do these on my calculator. My first answer is -0.23. I'm rounding there. And my second answer, yeah. It's 2.23. Okay. What the hell are these things? What are these answers? What do they represent to us? Now these numbers have meaning. What is the meaning of these 2 numbers?
2 points on the X-intercept.
Yeah, it's where on the x-axis this parabola actually hits, okay? So I'm going to be able to plot these like points, and I'll do that at the end. But right now, I need to keep in mind that these are going to be points on the x-axis, right? So remember this picture up here that we had? We just found where those 2 blue points are. We just figured out where they are exactly. And we also know where the vertex is. So we've got a lot of this graph, don't we? We have the vertex and 2 of those points. We've got a lot. There's one more piece of information that we want. This is step 5. Find the Y-intercepts. So the Y-intercepts are actually the easiest to get out of all the things we've done, the y-intercepts are easy because all you have to do is plug 0 into the function. So that means you're going to go to the function, right, which was up here, this thing in blue. Just replace all your x's with zeros. So it'll be -2 0 squared plus 4 times 0 plus 1. Basically, everything here with x's goes away. All you're left with is that plus 1 at the end. So your answer is 1. And this is a point on the y-axis. We should only ever have one of those. Okay, y'all ready? Step 6, time to draw a picture. All right. Now, when you do this for a test, it doesn't have to be perfect, okay? You just want to make sure you label everything. That's the most important thing. So when I go to draw this picture, the first thing I'm going to do is start with my vertex. My vertex was the point 1, 3. I'm actually going to mark it like this. Here's 1, here's 2, here's 3, here's 1, here's 2, here's 3. So I'm going to go and put my vertex right there. That's the highest point on my graph, and I'm going to label it 1, 3. Now my parabola opens down, and it hits the x-axis at -0.23. That's the first x-intercept I have. So look at your graph. This is -1. -0.23, we're going to kind of eyeball this, approximate it. I'm going to say it's about right there, and I'm going to put a little label on that. -0.23. And my other x-intercept is +2.23, which is going to be about right there. And where's my y-intercept? That 1, right? Which is right there. Okay, there it is. Those are all the points that we need. Now we're going to draw a picture. Now remember I talked about the axis of symmetry, right? So what I want you to see is that when we go to draw this, we're going to start at the top. We're going to draw kind of a U connecting these dots the best we can. And then on the right-hand side, we want to draw kind of like the same picture as best we can. And notice at the top here, right, at the top there, it's a U shape. It is not a sharp corner, okay? Don't draw a sharp corner in there. That's not, parabolas aren't sharp corners. Parabolas are rounded off. So make sure you're, whoa, that's not what I want. You can get the idea. Just make sure you're clear that that's rounded up top. And that's it. That picture right there will get you full credit on the exam, on an exam question. What do y'all think?
It's a lot of steps though, but
Yeah, it's a lot of steps. So what I think I'm going to talk about on Wednesday is what I'm going to provide you on the test. Like I'm going to give you the quadratic formula. I'm going to give you the vertex formula. I'm going to give you the steps, okay? I'll provide all of that for you. You just need to be able to execute them, okay? So that'll come more as like a separate page that'll be attached to the back of the exam, or maybe I'll send it as a different file where you'll have all of that there. So kind of like these steps kind of typed up a little nicer. I'll give you the quadratic formula and the vertex formula.
Yeah, because I don't think I'll be able to remember all those steps, to be honest, when it comes to the test.
Yeah, I understand. I understand. Summer class, we're going to be testing on this in a week, so I understand you don't have a lot of time to like absorb this and remember it, but I will give you that. Okay, let's go back and I want to take a look at the homework right now. Let's see what the homework looks like. Okay, homework graph. Is that it? Yeah, okay. So the homework here. Let's take a look at this first one. So here's what I want you to do for your homework. I don't want you to worry about that, or that. I want you to go through the 6 steps. When you do the 6 steps, you are going to wind up figuring out what the vertex, X-intercepts, and Y-intercept is. That's built into the 6 steps. Don't worry about finding the axis of symmetry. The domain and range we're not even going to talk about. So that first problem I think is doable. Let's see here. This next problem is doable. Same thing, same instructions. I'm just trying to look at and see if there's anything interesting. No. Yeah. Okay, yeah. So that's the homework. So let's do this. It's 1:17. Why don't we do the breakout rooms again? And I'm gonna let you all work on the first homework problems, you know, as groups. And once your group has gotten the graph, check with me and I'll tell you whether or not you're right or wrong. And once everyone has it, we'll call it a day. All right? So everyone write that function down, x squared plus 10x plus 26. And I'm going to create some breakout rooms. You all can go in there and work those out. All right, there you go.